So welcome to simulation models. We have covered most of the content in this lecture in class, so I'm just going to briefly go through the notes and put more emphasis on the calculation that we did also in class, the simulation calculation. So the first learning outcome, we talk about an overview of simulation. So in the notes, as you can see, it says what is simulation. So the notes say a lot of variety of things regarding simulation, but the one that I enjoy the most is the one which says simulation is the imitation of the operation of a real-world process or system over time. So the act of simulating something first requires that a model be developed. This model represents the key characteristics or behaviors or functions of the selected physical or abstract system or process. The example that I usually love to give is the one for the training of pilots, where they come up with a model or a simulator which takes into account all the variables involved with flying and put them all together in that model or that simulator, such that if someone goes in that simulator, they are able to have a real experience of what flying is, you see, so that when they actually fly the actual plane, it becomes easier. So that's the whole purpose of simulation. We need a model that sort of imitates the operations of the real world process or system over time. So that's simulation. So let's look at some of the uses of simulation. The first one, it's a risk-free environment. So simulation modeling provides a safe way to test and explore different what-if scenarios, then also to save money and time. So virtual experiments with simulation models are less expensive and take less time than experiments with real assets. So that's also another use of simulation. Then also there's an issue of visualization. So simulation models can be animated in 2D or 3D, allowing concepts and ideas to be more easily verified, communicated and understood. Then also insight into dynamics. So unlike spreadsheet or solver-based analytics, simulation modeling allows the observation of system behavior over time at any level of detail. Then also there's an issue of increased accuracy. Simulation model can capture many more details than an analytical model, providing increased accuracy and more precise forecasting. And also handle uncertainty in operation times and outcome can be easily represented in simulation models, allowing risk quantification and for more robust solutions to be found. So these are the uses of simulation. You can also look at them as sort of advantages of simulation. You see, so you need to be able to briefly discuss the 6 or even more that you can find during research. Then in the learning outcome 2, look at the basic process of simulation or the simulation process. So it involves about 7 steps to 10 steps, but in our notes we've got 9 steps. So the first one is to define the problem or problem definition. Second one is project planning, system definition, model formulation, input data collection and analysis, then model translation, verification and validation. So most of you, we have already had this question in exams, and most of you did very well, so I won't really spend much time on that, but you need to be able to explain the simulation process. Sometimes give you 7 processes depending on the source that you consult. I'll still be okay with that. Then learning outcome 3 talks of the types of simulation. So for the Monte Carlo or risk analysis simulation, in simple terms, a Monte Carlo simulation is a method of risk analysis. Businesses use it prior to implementing a major project or change in process, such as a manufacturing assembly line. So Monte Carlo is usually used for risk analysis. It's one of the very useful simulation types of simulation in the business sector, in the business environment. Then there's also agent-based modeling and simulation, which examines the impact of an agent or the system or environment. In simple terms, you can think of the impact a new laser cutter or some other factory equipment has on your overall manufacturing line. So that's another type of simulation. Then also discrete event simulation. A discrete event simulation model enables you to observe the specific events that result in your business processes. For example, the typical technical support process involves the end user calling you, your system receiving and assigning the call, and your agent picking up the call. You would use a discrete event simulation model to examine that technical support process. You can use direct event simulation models to study many types of systems, e.g. healthcare, manufacturing, and for a diverse range of outcomes. So that's another one. Then we also have system dynamics simulation solutions. This is a very abstract form of simulation modeling. Unlike agent-based modeling and discrete event modeling, system dynamics does not include specific details about the system. So for a manufacturing facility, this model will not factor in data about the machinery or labor. Rather, businesses would use system dynamics models to simulate for a long-term strategic level view of the overall system. So that's another one. Then there's also have analog, continuous, and discrete. So what I usually require you guys to do is to remember at least 4 that we can explain for at least 5 marks each. Then the 4th learning outcome talks about simulation of approaches. So we talked about the Monte Carlo. We go deeper into it. We look at the advantages of it. So we need to look at that. Then there's also computer simulation processes as well. You also need to read about that. So the Monte Carlo is usually the most used one because of it analyzes risk. So you need to understand its advantages, which are like the probability distributions within the model can be easily and flexibly used without the need to approximate them. Then also the correlations and other relations and dependencies, such as if statements can be modeled without difficulty. The level of mathematics required is quite basic. Software can be used to automate the tasks involved in simulation. The behavior of and changes in the model can be investigated with great ease and speed. So those are the advantages of the Monte Carlo simulation. Then also you need to explain computer simulation processes as well. Then in terms of learning outcome 5 is just the benefits and drawbacks of simulation, or the benefits, or we can say the advantages and disadvantages of simulation. We have already done a question like that in your assignments and also in the semester test, and most of you did well, so I won't spend much time on that. It's quite straightforward. Then we also have inventory control simulations. We've done that also in class. So I won't spend that much time on it. I'm going to then you need to be able to define these terms. Many of you have already defined them. You did very well. So I won't also spend much time on that. What I'm going to focus on is the example for inventory simulation. Not example 1. That one you can do it on your own during your spare time. It's a very straightforward one. The answers are there. I just want to emphasize the one that will always appear in your tests and exams. This is let's see, it's example 2, this one. So you need to be able to calculate this one. It's very, very important. So I'll just re-explain it. I've explained it probably almost more than 3-4 times in class, but for the benefit of those who might have missed the explanation, or those who were not in class, I'll repeat it. So the question says, a baker keeps stock of a popular brand of cake. Previous experience shows the daily demand pattern for the item with associated probabilities is given below. So like what is mentioned there in tests and exams, I'll change the random numbers, the sample size, number of products in a packet, etc. So the key is to understand the calculation, where the numbers may be changed, but if you understand the essence of the calculation, then it will be easier for you. So the demand, daily demand, it's 0, 10, 20, 30, 40, 50. So the probability for us to have a daily demand of 0 is 0.11, which in percentage terms it's 1%. Then demand for having 10 units demanded is 0.2 or 20%, and so forth. These are the random numbers. So in other words, we generate 10 random numbers representing 10 days. Then we have these 10 numbers. Then we simulate the daily demand for the cakes on the basis of this. So let's look at how this can be done. Just give me a second. Okay, sorry about that. So we were looking at the random numbers. So the random numbers, they represent the demand. So for each day, you see, so the random numbers are out of 100. It's 2-digit numbers. The first number is 00. Second number is 01 up until 99. Those are 100 numbers. So the first thing that you do is to come up with the random number intervals, and also maybe let me put it this way. You come up with this table here. That's the first thing that you come up with. The first two columns are your first two rows in your question there, in the table in the question. And the cumulative probability, you just add the first probability, it's 0.1, then this 0.1, you add it to 0.20, you get 0.21, 0.21 plus 0.15, you get, and so forth. So that's cumulative. So that's what you do. And the random numbers, the first one, so these probabilities, so it represents the numbers, random numbers that are represented by each group. So the first probability says 0, 1, which means it's the first one number, which is 0, 0. Then the next 20 random numbers, it's 0, 1 to 20. Then the next 15 random numbers is 21 to 35. The next 50 random numbers is 36 to 85. The next 12 random numbers is 86 to 97. Then the last two random numbers is 98 to 99. So how do you get also these random numbers, these intervals? So what you simply do, you say, so your next interval is always the next number after the last interval number, you see, or after the upper limit of the last interval. So since in this one we only had one number, it could have been 0, 0 to 0, 0. Then you say 0, 1, then you add this to 1, you get so that's 0, 1 to 20, that's, so which is 0, 1, so it's 0, 0 plus 20, you get that one, you see. That's the first 20, that's the second 20 numbers. Then the next number after the upper limit of this interval is 21, you see. Then you say this 20, you add this 15, you get 35. Then the next random number is 36. Then from this 35, you add 50, you get that one, and so forth. So there are many ways of doing it, but the most important thing is to make sure that your intervals don't overlap and all numbers have been captured. And they should always end with 99 and start with 0, showing that all the 100 random numbers have been catered for. Then now, we use now the random numbers that we generated. These ones you always be given. These ones, the 40, 19 and so forth, these random numbers, they are always given, they are always in the question. So now you see, where does it fit? 40, in which random number interval does it fall? It falls in this one. And in this random number interval, what is the daily demand? It's 30. You see that? That's your 30. Next thing, 19, it falls in this interval. What is the demand? It's 10. Then you do everything for those ones. Then you add, so this represents the simulated demand for each day of those 10 days. Up until you get to 10 days, then you add, you get 220. So that's the total demand for the 10 days. So that's the expected demand or the simulated demand for the next 10 days. Then the average demand, you divide by 10, you get 22 units per day. So that's your average demand. So that's the example that we did in class, and that's the one that I will be asking for you in the exams. It's very important for you guys to know it. Then in terms of learning outcome 7, the queuing methods, this one I'm going to leave it out simply because the calculation that is required, it won't work in this method of teaching. It will need us to be in class so that I can go with you guys step by step. Otherwise, if I do it on this one, it's going to be very confusing and difficult for everyone, something which I wouldn't want to do. So learning outcome 7, please ignore it. We are going to do it at some stage if we get an opportunity, but I think what we have done so far is sufficient to give you guys a good understanding of what is simulation and to actually work with the numbers. So learning outcome 7, for now, let's leave it out. We're going to do it at a later stage. Otherwise, all the best, guys. I wish you the best with your studies, and also keep safe during these difficult times of coronavirus. Okay, so our lecture ends here.